Let's take a look at one last example from the power outage data set. With alpha equals 0.1 significance, what is the mean number of customers without power when outages occur in the Gulf region? Okay, so first off, we want to take a look at the region column and find out what the sample size is within the Gulf region. And if we do that, we see that n equals 8. There are 8 outages that occurred within the Gulf region. Okay? And we're interested now not in outage duration, but in the average number of customers. Okay? So we want to build a confidence interval for the population of customers affected by outages within the Gulf region. Okay? We know that alpha is 0.1. Okay? That means that we want a 90% confidence interval in this case. Okay? So we go back to our data set for those 8 customers, or pardon me, for those 8 outages in the Gulf region. We want to find y bar. We use that average function in Excel again, and we get this time 168,243.8 customers. Okay? And if we use the standard deviation function, again, for those 8 outages in the Gulf region, again, for the customers column, the customers affected by the outage, we get 188,476.1 customers. Okay? Again, this is a standard deviation, so we are in just the units. If this were variance, we'd be in units squared or customers squared. Okay? We know that the sample size is 8. Therefore, the degrees of freedom is 8 minus 1, n minus 1, which is 7. So we have 7 degrees of freedom for this problem. Okay? For 7 degrees of freedom, we can either look that up in the lookup table, go down to the 7th row, over to the alpha over 2, 0.05 column, okay, to find this value of t. So this is for 7 degrees of freedom, alpha over 2, 0.05. Okay? If we do that, we find that the t value is 1.895. Okay? Also, we could use the t inverse function in Excel, inputting the two-tail probability and the degrees of freedom, and we'll get something like this, probably with a few more digits afterward. Okay? So we have everything we need now to calculate the confidence interval, the 90% confidence interval. So we have y bar plus and minus t of degrees of freedom 7, 0.05 in the upper tail, times s over root n. Okay? That is 168,243.8 plus and minus 1.895 times 188,476.1 over root 8. Okay? If we do that, we get a lower bound value of 41,967.9 and an upper bound value of 294,519.7. Okay? And that's in customers. So based on our sample of size 8, we are 90% confident that the true population number of customers that are affected by outages in the Gulf Coast region would be between 41,967 and 294,519 customers. Okay? So, a few takeaways from the example problems that we just discussed. First, I strongly encourage you just to take a look at some of these Excel functions. Okay? Use the Excel help. Excel help is very good at explaining exactly what needs to go into a function. So if we've got the t inverse function, for example, what needs to be read in for us to use that t inverse function? It's very important to check this out and just do a few examples. Compare this result to the t lookup table. Make sure you're inputting the right stuff. Okay? Plus, the Excel help provides some examples of some values that could be entered in and what the result is. Also, and I can't stress this enough, work out as many examples as you can. You know, we just worked out 4 examples, but you could do any number of examples to help you pick out what exactly are the parameters and what's the problem asking for. Okay? It's very important for the exam especially. You can't teach yourself stuff during the exam. You have to learn this stuff in advance of the exam. Learn it by just doing a bunch of problems, okay? And also remember that if you don't have the exact degrees of freedom in the t-table, you can always use Excel, okay? If you don't have Excel, then round down. So round down to the closest value of the degrees of freedom that appears in the row in the t-table, okay? Again, do a bunch of problems and have fun.